David Can here with another question from your Hayes and Harris Math SL textbook. This is Chapter 6A.1, Question 2, Parts A and B. And what we're looking at is solving a quadratic through factorization. Now what we have here is a couple of quadratic functions. I know these are quadratic functions because I have a term which is squared, a term to the first power, and a constant term. This is the same on this side. I have a square term, term to the first power, and a constant term. Now, if I want to solve by factorization, usually the first step is to get things in order. That means that the squared term is first, followed by the term to the first power, followed by the constant term, and I want it all equal to 0. But in both of these cases, that's already done for me. It's already in that form. It's ready to be factorized. So let's see if we can break them up. So for part A, I'm going to split this up into two things which are multiplied together. And the first thing that I notice is that the first term and the last term are both squares. 4 is 2 squared, or negative 2 squared, and 9x squared is 3x times 3x. So the very first thing I'm going to try is 3x and 2. Now I know that I want a negative term in the middle, so it could be plus 2 and plus 2, but it's going to be minus 2 and minus 2 to make that negative. So now let's do a double check. 3x times 3x is 9x squared. Negative 2 times negative 2 is positive 4. And negative 2 times 3x is negative 6x. I have to do the same thing with these two, so I get two lots of negative 6x for a total of negative 12x. Looks good to me. Next comes Null Factor Law. Which tells us that if two things are multiplied together to give us 0, then either or both of them must be 0. So this means that 3x take 2 has to be equal to 0, or 3x take 2 has to be equal to 0. In this case, that's redundant because they're the same. So I can just take this out and say 3x take 2 has to be equal to 0. Solving this for x, I get 3x equals 2, or x equals 2/3. Part B is going to go similarly, but I'm going to need to use a different factorization. It's not going to work out being exactly the same. I'm still going to split it up into two groups. Looking at 2x squared, though, that's not a perfect square. In order for this factorization to work out cleanly, I'm going to need to use 1 and 2, multiplying 1 and 2 together to give me 2. So I'll start with 2x and just x. Similarly, 7, we can only get it by multiplying negative 1 and 7 or negative 7 and 1. Anything else, and it's just not going to work out cleanly. We're going to have to turn to other tools to solve this, like completing the square or quadratic formula. Since we're told to solve by factorization, we can assume that it will work out cleanly. So now the question is, do I want to multiply by 7 and 2 or 7 and 1? Well, looking in the middle, I want to make a really big number. I want to make 13. So if I take 2 and 7 and multiply them together, that's going to get me close. That's going to get me to 14. I want it to be negative 13, so let's call that a negative 7, which puts plus 1 in here, and we'll see if this works out. 1 times negative 7 gives me negative 7. 2 times 1 gives me 2. 2 times negative 7 gives me negative 14, but I have to add in 1. Negative 14 plus 1 is negative 13. So this looks like it works. Next up, I'll use the same null factor law, which allows me to split this up and say that either 2x plus 1 equals 0, or x takes 7 equals 0, or both. So and or, one of these at least has to be true. So this means that 2x equals negative 1, or x equals negative 1/2, and x is equal to 7. Both of these are solutions to this equation.